Good afternoon, everyone. Can everyone see my screen?
Yep.
Awesome. We are the Surge team. I'm Travis Schwartz.
And I am Spencer Stream.
And we will be sharing our presentation about our application today. So the application that we've created is for a pretty unique and pretty awesome set of sponsors. So the Social Unrest Reconnaissance Gazetteer and Explorer, also known as Surge. They're a research group. They're primarily focused on understanding social unrest events and their interactions, importance, and context within modern societies. The team is mostly composed of researchers, both graduate, undergraduate, and at the faculty level within UNL's own computer science department. So our sponsor stakeholders that we've been interfacing with throughout the senior design year have been Dr. Soh. He is from the University of Nebraska-Lincoln. Dr. Ashok Samal, he is also from the University of Nebraska-Lincoln. And Dr. Depti Joshi, and she is from the Citadel, although she spent some time at UNL. So just real quick to go over our development team. I'm the tribe lead and development manager for the Surge team. Mr. Andrew Hazel is our project manager, or product manager rather. Spencer?
Okay, I am Spencer Stream, the process specialist for Surge this year.
Ms. Erin Reed is one of our developers. Mr. Sun Leong Yip is one of our developers. Mr. Zheng Yan Yop is one of our developers. So the problem that the problem domain that we've been facing throughout this year is to incorporate a wide variety of spatio-temporal, sociological, and climatological data on a map layer to visualize that. We were to combine this with data-driven techniques and then using model-driven methodologies like that aforementioned map layer and some filtering capabilities. We wanted to develop effective models for anticipating social unrest events and other kinds of violent and political, socio-political interactions, and then create a usable, scalable application that is going to improve on an already pretty unique legacy version. So that's those were our problems when we went into creating our solution. And I'll hand it off to Spencer to talk a little bit about that.
Thanks, Travis. So I'll talk about the solution that we built this year in senior design. As Travis kind of mentioned there at the end, Surge did exist as an application before the school year started. So we were given the option to either enhance the existing application or to create our own from scratch. And our team decided to take the opportunity to create a brand new application which employs a few more modern technologies. So what we've built is a web application which utilizes Google Maps API to visualize and plot unrest event data on the world map. Users can filter and visualize events by unrest category, a geological region, the date of an event, and many other factors. Also using the Google Maps API, we were able to highlight various infrastructure on the map. We can then layer categories of unrest events based on their colors, and then you can even update the style and look and feel of the map. And all of these are just extra features that help the user to search for events. And finally, one of the goals that we set out to create this year was to create a more usable interface based on the application design. This is something that we thought would help improve visualizing unrest events from the legacy version that started before we got to the project. So here we have a few screenshots of our application. This one here shows the filter menu, which is kind of a user's main interaction point with Surge. Users can choose and select options, which will help them view events on the screen. And one of the things we do in order to give a broad sense of what your options are doing is display to the user how many events will be loaded once you apply. A few of the options, as we talked about earlier, are date, unrest event category, the country or region where an event occurred, and also the data source for where these are being pulled from. And additionally, you can also use an area filter to draw a rectangle on the map to further refine your selection. So once a user goes ahead and clicks that apply button, the events will load and they will show up here as clustered markers. And we decided to go with clustering because it allows a high performance during the runtime of the application, even for large numbers of events. And so once all the events are here on the screen, the user can interact and zoom into the map, and eventually they will be displayed as markers. You can see one here at the top of the map, and it just helps to give more detail about the locations of where these events are occurring, and it helps both researchers, users, and even policymakers eventually to understand how these events are occurring and where, and possibly predict why. So I'll now talk about some of the values and the highlights we got, both developing the Surge application as a team and also what Surge values can provide to users. So one of the things we worked on is being able to search events on a global scale. When we first started the project, Surge was only displaying events from 19 countries, but we have created a framework which allows events to be visualized across the entire world. So we believe that this is something that will definitely help a greater variety of users if they want to use this application. Additionally, we mentioned that we have created a more user-friendly design compared to the last iteration of Surge. We also think that it is easier to pick up and get started with compared to the legacy version. And a couple of things that we learned as a team, one of which being scalability can make or break the user experience. As of today, there's a little over 1 million events in the Surge database, and trying to display all of those on the screen at a time proved to be one of the most difficult parts of this application. But within the last few months, we've actually made some pretty good progress on cutting those wait times down, and in some cases, those were cut in half. So we're very proud of that. And one more thing that we learned as a team is how to compromise our development team's workload with the sponsor priorities. We learned that trying to do an ad hoc approach proved to be difficult to show what we needed to be working on, but we eventually met with the sponsors to create a priority document, which better guided us what would be helpful for this application going forward. So with that, we want to thank everyone for coming to this presentation. If you haven't already, please join our table, virtual table. The link is here, and Travis could post it in the chat possibly, so you can go there and come see it in action.
I will do. And then just real quick, wanted to give a special thanks to our UNL sponsors, Dr. Soh and Dr. Small, and Dr. Joshi. Thank you for giving us the opportunity to work on this incredible project. I will go back and grab this link real quick.
And while they do that, let's just give a thank you to our presenters. They did a great job. If you could use the clap emote or type out in chat, just a congratulations to them.
Thank you.
Our virtual table link should be in the chat right now.